All right, let's talk about functions. Functions, again, we've talked about in class before, are just a relation where you're relating inputs to outputs. But when we talk in algebra, we like to have things written in what we call function form. So a function form is just to say that y is going to be a function of x if and only if here it's isolating the y, right? If the y is all by itself and x is in the mix, as I like to say. X is sort of on the other side in the mix. So you'll notice the two equations we have down below here, 3x plus y equals 4 and 8x minus 2y equals 4. Well, both of those have a 4 on the right, but again, that means they're solved for 4 essentially. That's not that helpful for us. What we want to do is solve for y. We want to get y by itself. Now notice we have two variables though, so this isn't like solving regular equations where we're going to end up with just a nice little y equals a number, right? We're not going to be able to get rid of x. We don't know what x is equal to. But what we can do is say that 3x plus y equals 4. And if I want to get y by itself, right, get that totally by itself, I'm going to leave the y alone. I need to get rid of this 3x because they're added together. I'm going to subtract 3x on both sides. And in that case, again, the 3x minus 3x cancels. We get y equals. Now notice y is totally by itself, right? The equation now is y is a function of whatever we put on the right. Because 4 and 3x aren't like terms, we're just going to say 4 minus 3x. And that would be our answer. If you prefer to write your variable first, that's perfectly fine as well. You could always have written y equals negative 3x, but now it's a positive, right, plus 4. Either one of those would be just fine. But again, this now says y is a function of x. If we named the x, right, for the input, we could find a bunch of y values, right? We like to have that solved for y. Let's try that same thing over here at the right. We've got 8x minus 2y equals 4. Again, I'm going to leave the y alone. I want to get y by itself. That means everything else needs to go. So to start off with, again, there is a 2 multiplied by y. But remember, when we're solving equations, we're sort of doing backwards PEMDAS. I'm going to start by getting rid of that 8x. Get rid of the adding and subtracting. So I'm going to subtract 8x on both sides. Those two things are going to cancel away, right? 8x minus 8x is gone. This just became a negative 2y. Again, x and 4 here, we got negative 8x and 4. They're not like terms. So I'm going to go ahead and write my variable first, negative 8x, again, positive 4. In order to now get y by itself, let's divide away that negative 2, right? Now remember, I'm going to need to divide the whole side. When we divide everything. So we'll divide by negative 2. Again, those two negative 2's will cancel away. Negative 2 divided by negative 2 is 1. And 1 times y is y. And in this case, we can do a little distributive property, right? Negative 2 divides here, but it's also going to divide over there. So in that case, negative 8 divided by negative 2 is 4. And don't forget, there's still an x on that first term. Positive 4 divided by negative 2 is going to become subtraction instead of addition. It's going to be a negative 2. And that is a nice clean answer over there. Notice both equations now solved for y, right? Isolate the y with x in the mix. X is in amongst all that other stuff, right? The multiplying and subtracting going on. Well, in that case, when are we going to use this kind of thing? Well, when we use formulas, we usually have them solved for one of our variables, right? Such as this area formula down here at the bottom of our screen. A equals the area of a rectangle, right, would equal length times width. But what if we knew the area and we knew one of the dimensions, length or width, right? We could solve our equation to be more advantageous, right, to help us out a little bit more. Same thing that we could do with the functions like we did on the last screen, or with our distance formula, right? Dirt, d equals rt, distance equals rate times time. Or as we're going to do up top here, what about temperature conversion? We have an equation that says the Celsius temperature, right? And notice we'll go up top here. Celsius temperatures are equal to 5/9 of the quantity of Fahrenheit temperature minus 32 degrees. Well, what if I knew the Celsius temperature though and I want the Fahrenheit? I would much rather be solved for F rather than plugging in for C and then solving this equation every time, let's get that Fahrenheit temperature, right, all by itself. Let's solve the temperature formula for F. Get that F variable, right, all by itself. Well, in that case, I've got two options. I can either distribute my fraction, which I'm thinking 5/9 of 32 might not look too pretty. So instead, I'm going to go ahead and get rid of what's already there. The last thing happening is that multiplied. So the first thing I'm going to do is divide that away. And remember, anytime that we divide by a fraction, you really are just going to multiply by its reciprocal, right? So we're going to say 9/5 of C is equal to. On the right side, again, we've canceled. And we're down to F minus 32. So if I add 32 to both sides, we'll end up with F all by itself on the right and 9/5 C plus 32, right? Not like terms. One of them has a C in it, one doesn't. So 9/5 times C, I don't know what C is, can't do it. Then I would add 32 when I'm done. But now if I knew a Celsius temperature, right, I could plug in that Celsius and quickly multiply and add and find the Fahrenheit. Great way to solve an equation. Solved for a different variable, right? The initial equation was solved for C. The new equation, again, is solved for F. Let's take a look at one more problem, just showing you somewhat what these might look like to you. And we got kind of a messy one going here. The surface area of a cone. What if I wanted to take that big surface area formula up top and solve it for L, so that then I could later on plug in the fact that, hey, if I know what S is and I know what R is, rather than plugging in here, here, and here, and solving for that L, right, that would be in the middle there, I could instead plug my numbers in and just calculate the answer. Okay? So let's go back. And now you got to be a little bit careful in your homework when you do this, because it's very tempting to just say, oh, why don't I just plug those numbers in and solve? Well, that's because that's not what they were asking for. They want us to rewrite the formula. So the first thing I'm actually going to do is sort of cover this up, right? I'm not even going to tempt myself. Let's just solve the formula. S equals, well, notice the first thing I see is that I've got a big term over here. Doesn't have an L in it. So I'm thinking let's get rid of that first. If I subtract pi r squared from the right side, I just need to do the same on the left. So we're going to have S minus pi r squared equal to, and notice that the only thing left on the right is here, pi r L. Well, now if I want to get L totally by itself, then I need to divide. I'm multiplying by both pi and r. So I'm going to divide away both pi and r. Right? And now I have a formula. L equals S minus pi r squared over pi r. Okay? Apologize for those pi's there. They don't look too good, but here you go. You get the idea. So that now we can go back down to the bottom, right? And let's solve this thing. Find L, knowing that S is 283, minus pi, of course, which has its own value, right? 3.14 is just an approximation. I highly recommend use the pi button on your calculators, though. Try to stay with a few more extra decimal places there. And again, r squared, so we got 5 squared there, all over pi r, pi times 5. Now, this is a great time to remind ourselves, if we're going to type all that in our calculator, there isn't a single variable on the right side there. I can just type it all in. But I want to make sure that I end up subtracting up here before I end up dividing. And in order to do that, I'm going to put parentheses all the way around when I go typing onto the calculator here. Okay? So you can hear me typing, more than likely clicking away, parentheses 283 minus 5 squared times pi, close that parenthesis, divided by, right? I want to have this whole thing on top typed in. before I divide by. And again, because I want to make sure these multiply, I'm going to go ahead and put a parenthesis around there as well. Divided by 5 pi. And when I hit enter, we get 13.016. So make sure you try typing that at home as well. Make sure you get 13.016. If our radius was measured in centimeters, I'm kind of assuming our length would also be. So we're talking in centimeters. And we have our answer. Again, make sure you get that same answer when you type in. If you don't, talk to your teacher. They can probably help you figure out what went wrong. If you have any other questions, talk to them as well. And otherwise, have a great day.